So I'm going to start off by talking a bit about where I come from and the background of what I do and my life, and then I'll touch on the technical stuff, which is what I'm kind of strongest on, and also talk a little bit about the dissemination of small wind as a tool for development workers around the world. The various organisations that I've worked with, a few anecdotes about them and stuff like that. So to start with, Scoraig is close to Ullapool. It's halfway between Ullapool and Gairloch, so it's quite remote. It's one of the few communities in the UK that's off-grid. So I went there deliberately because off-grid living is something that I enjoy. I can't justify it. I'm not a crusader for off-grid living. I don't think everyone could possibly live off-grid, and it'd be horrendous if they did. But it's something that I enjoy doing, and so I moved there in the mid-70s, initially without any electricity. And when I say without electricity, actually I wasn't completely without electricity, because I had a 12-volt car battery that I would charge up when I went to town to get shopping. About once a month I would charge up the car battery. And it's quite interesting that parallels the way that electricity, the introduction to electricity use is actually very similar in the developing world. But yeah, I lived without electricity for a little while, a couple of years, and then just using oil lamps mainly for lighting and stuff. This is a little bit more of the geography of the place. There's no road access, so you have to go across the water to get there, or walk in around the cliffs, which I don't really do for years on end because it's much easier to go across by boat. And we mostly use wind for our electricity there. So these are some sort of ancient historical shots. That's my first wind turbine that I built, which is a rooftop one, the first and only. I'm quite a campaigner against rooftop wind power. That was very, very noisy, actually, having that thing on the roof. And at the time, there were no trees around, so it was quite a windy place. But typically, actually, the roofs of buildings are rather sheltered, rather turbulent, and they've got all kinds of issues with noise, turbulence, safety, etc. So I'd like to make the point that I'm not a follower of the rooftop wind movement at all. My early machines were mostly made from automotive generators, dynamos. Most of them actually in the end were with this dynamo from an Austin Champ Jeep, weighs about 25 kilos. And the beauty of it was that modifying it from working at 24 volts down to working at 12, we get it to cut in at 500 RPM. Big challenge with small wind turbines is to get something that will work at low enough RPM and have good enough part load efficiency to actually just put blades straight onto it and be able to work in low wind speeds. So for many years I worked with those sort of motors, and then more recently I've started using permanent magnet alternators. When I say more recently, it's been kind of the last 20 years, but in the beginning I didn't have access to the magnets that I needed to do that. And then as part of the whole sort of package, you have to put the machine on a fairly tall tower. So we developed some quite low-cost ways of doing that, using steel water pipe and fence wire for fairly tall towers to get up above all the surrounding obstacles and catch the wind. It's not been without its setbacks. There have been some learning curves, and I think most people who play around with putting up guide towers get to discover that they're more complicated than they initially thought. I've become reasonably adept, obviously, over 30 years, but this happened only the other day. And I kind of knew that it was a dodgy situation. These guys, the top guys, weren't close enough to the machine, so there was too much leverage there. The pipe was kind of borderline. The guy angle was too steep, and also we got a really horrendous storm about a month ago, which, and on this particular site it's very, very turbulent. So the combination of these factors caused the guys to stretch enough that the whole thing just buckled and collapsed, and the machine ended up dangling up its wires. Small wind is actually very, very prone to problems. I have to be very frank about this. If you go in for small wind, it's not an easy ride. If you want an easy ride, go for PV, go for hydropower. I've done a bit of hydropower and it's an absolute doddle compared to small wind. And I would say partly the reason that I'm involved in it is just because of the challenge, and you get kind of addicted to struggling against the difficulties. But people who actually know the industry will recognise that there is a pattern that small wind turbines do tend to be very unreliable pieces of machinery. They're an engineering challenge. I don't know exactly why it is, but I think it's because the wind is such a fickle, variable force. You know, the power in the wind goes with the cube of the wind speed, so it can be very, very light, or it can be thousands of times more powerful. And you're up there in the weather, and everything's changing. A lot of fatigue and corrosion and so on. But initially, I thought it was just me, but then I began to realise that this was kind of endemic in the industry when I started working with the professional manufactured machines, that they are all somewhat prone to problems more than your average piece of machinery. So like I was saying, car batteries are used all over the world as an entry point for electricity use. Well, I suppose perhaps the lower entry point is possession of a cell phone, a mobile phone. But if you want to have maybe a couple of lights or listen to the radio, watch telly, the typical pattern is to take the car battery away to the store or something like that and get it charged up, rather than actually having an electrical system in the home. Traditionally, that's been the way that people have got their electricity in the past. And wind-generated electricity is a very fluctuating source, so it doesn't really work without a battery. So this is an example of the sort of variation that you'll get with wind power. You can't really just have a wind turbine and connect it directly to your lights or your radio or your TV or whatever, because there's always going to be too much or too little electricity. Even if the wind speed is only varying that much, the power, I don't know if you can see in percentage terms, is varying much more wildly because it depends on the cube of the wind speed. So you really do need to have a battery store. In Scoraig, the way that we dealt with that in the 1970s and 80s was to get second-hand telephone exchange batteries. They were modernising all the telephone exchanges, so we were very lucky that we were able to get our hands on fairly large battery banks from these telephone exchanges and use them. And second-hand batteries can be quite a good way to go to minimise costs and to maximise the sort of recycling, or minimise the impact, if you like, of the use of small wind systems. It looks pretty ragged, but these batteries actually were designed for 25 or 30-year lifespan, so they're very much better technology than the car battery. Car battery is not designed to be deep-cycled at all, and so although its use is very widespread in the developing world, it's only because they're cheaply available. It's not because they're suitable technology for the job. I'm kind of rabbiting on here, I'm aware, whereas, like I said at the beginning, I would much rather be having a dialogue. So if anything comes to mind, you know, that you want to ask me, please fire away. And because of this variability that I was talking about, wind actually works best in a hybrid system. I think a lot of people think, well, we're going to build a wind turbine and we're going to try to use it to generate electricity, and they become obsessed with the wind turbine, but actually it's part of a system, and it's often quite a small part of the system. Battery, like I said, is often as expensive, and it's an ongoing cost, you know, so that can be quite a major cost. It's very much worthwhile having PV input into an electricity system, especially with PV getting cheaper and cheaper and cheaper. So for a developing world project, I would definitely be looking at a hybrid system that will very much reduce your reliance on batteries. It's much greater than the sum of the parts, put it that way. If you put a bit of PV and a bit of wind, you're going to get a much more functioning system than you would if you put twice as much wind or twice as much PV in there, because they're it gives more diversity to the supply and makes it much more continuous. And it's very, very simple to feed them all into the same battery store. And then you can use that battery store either directly to run DC loads or through an inverter, is more common these days. You can also have a backup generator to charge that. Yeah.
If someone can only install one type of renewable, would you recommend wind or PV? Or would you
I would say it's very site specific. That's something yeah, it's great to have a question, because I glossed over the issue, but wind is very, very, very site specific. It does depend on having good wind speeds, and I think people tend to overlook that. You know, what you'll see nowadays is all these fancy looking gizmos, vertical axis, very clever, revolutionary new designs, and they're outside somebody's bedroom window, or they're under a hedge or something. You know, I've seen one in the botanical gardens in Edinburgh. The trees are towering over it. The thing's never going to move. 30,000 quid's worth of kit, and I think this is what people really do overlook with wind. It's a resource. You wouldn't give somebody a petrol engine if they never could get any petrol. You shouldn't put a wind turbine somewhere where there's never going to be any wind. And so you are looking for like coastal sites, hilltops, stuff like that. I would still come back to the value of mixing wind and solar as a hybrid. If you've got a good wind site, then you're going to get cheaper electricity from the wind turbine potentially than from the solar. That argument has actually been eroded quite fast because the price of solar is going down. But it is arguable that in the developing world, they're not likely to be able to introduce manufacture of solar PV because it's so capital intensive. Where in fairly primitive environments, they're never going to be able to set up a PV factory, but there's a reasonable chance of being able to actually build their own wind turbines. And that's not just an issue of economics there, then it becomes an issue of actual self-worth, social, appreciation that you're no longer just a consumer of electricity, you become actually capable of generating your own. And I think it's going to be a lot easier to generate your own electricity using wind power or hydropower than it's ever going to be using PV. If you look at what PV can do in very simple terms, the UK is not an ideal place for it. These are kilowatt hours a year. From a kilowatt of PV, you're going to get about 800 kilowatt hours a year. And this is the way you should look at energy sources. You should always be looking at how much energy per year am I going to get from it. If we start looking at the global picture, it becomes clear that all the PV ought to be being sent to Africa. It's a complete waste installing it in Europe, because it could be generating 3 times as much energy from the same piece of kit in these much, much sunnier locations. But there are windy places, but as I was saying, it's important to identify the resource. Here's a similar comparison for wind. What can wind energy do? And these are again kilowatt hours per year. Now, rotor diameter is very important. A 1 meter diameter machine is not going to give you a lot of energy, no matter what the wonderful, brilliant new invention, clever technology. Size matters. The wind is the actual resource. You have to catch it. The size of the disk is going to be critical. A 5 meter diameter one is going to produce 25 times as much energy, possibly more, probably more efficient. But also the wind speed is really critical. A 3 meter a second annual mean wind speed, which is what you get in an urban location, is not really going to be economic. 4 meters a second is probably marginal, depends on a lot of things, but you're going to be looking for 5 or 6 meters a second annual mean wind speed. And that really does mean that you need to be out in open country, coastal, hilltop, that kind of thing. Other than that, you'd be better off going with PV or the other various other optional technologies that are there. Another factor with wind that people don't appreciate is that it doesn't all come. A 1 kilowatt wind turbine is not going to be producing 1 kilowatt all the time, like I showed on that graph earlier. It's going to fluctuate like mad. And it's interesting to look at these curves. This is wind speed along the bottom. Now the wind turbine is going to produce power that goes up and up till it reaches its maximum and then kind of droops a bit. This is what we call the power curve. That's power in relation to wind speed. So this blue one is the power curve. Now, everybody always looks at that top point and say, right, it's a 1 kilowatt windmill, that's all that matters. How much does it cost? It's more expensive, less expensive than another 1 kilowatt windmill. But that's not the important thing at all. Like I was saying, what's important is the actual size, the rotor diameter, because most of the actual energy is generated in low winds. The reason for that is if you look at the distribution of wind speed, this is even quite a windy site. 6 meters a second annual mean is quite a good site. Most of the wind is actually going to be happening down here. And if you multiply the hours of wind by the watts or kilowatts that the machine produces, you get the kilowatt hours of energy at each wind speed, and you'll find that that peaks quite low down, nowhere near the top of that curve. What really matters is what the machine's doing in those lower wind speeds, and that's going to depend entirely on the swept area, how much wind it can catch. So those are the sort of things that you need to look at when you're designing a project. You need to look at the requirement for energy, you need to look at the wind resource, and then you need to size the machine appropriately to meet those needs. And you need to consider the whole system, including the batteries, the tower, the controls, and many of that, much of that might already be in place as a result of the fact that people are already using electricity, whether it be with PV, with a generator, or just carrying the battery off, and getting it charged up. But I would definitely consider a very inclusive approach where you have some PV as well as wind, and not just get obsessed with the fact that we're making a windmill that's going to generate the electricity in the story. Yeah.
Can you clarify for me, on the last slide it seemed like the higher wind speeds and the higher diameter turbine, thank you, was going to generate your most power.
That's right.
And then on your next slide, I feel like you're saying is your lower wind speed.
What I'm saying here is these lower wind speeds will produce less power. Mm-hmm. But the thing people don't realize, they always look at the power, they don't realize that what we're after is energy. Energy is in kilowatt hours. So it's all very well you produce a kilowatt for a few hours in giddy excitement in the middle of the night, but what you actually need is sustained energy, and most of the wind speeds that you actually get, you'll be somewhere down here on the curve. Now you multiply the hours by the kilowatts, and you'll find that you're actually getting your most kilowatt hours in this bit where you're only generating maybe half of your rated power. But because the hours drop off so dramatically for the higher end, that's where you lose out. So the top end isn't as important as people think, because the number of hours per year that the machine will spend in those higher winds is very few. That's the point I was trying to make with that curve.
Do you feel that wind turbines will be a viable source for like urban energy generation?
Sadly, I don't really see a place for a small wind turbine in the city, and I've found it very puzzling and alarming the way that they have been hyped. The rooftop wind thing, which I think is mainly blown over, but you still tend to see it coming up again. People get all excited about putting wind turbines on urban rooftops, and it just isn't the place for it, because if you actually measure the wind resource, it's quite low, very, very turbulent. There isn't a lot of energy in it, and there are all kinds of other issues such as noise and safety in there as well. So what you really need is quite a large machine as well. Most of the rooftop machines are quite small for practical reasons. And so in my mind, they're just greenwashed, they're toys. And I think it's important, to recognize and be aware of this trend, that what we're looking at here is gimmickry. It's not actually going to solve the problem. The architects love it because it makes their building look, sexy and modern and green. But if you look at the numbers, always ask, what are the numbers? How much energy did that actually generate? And then I think you'll find out what's going on. So returning to me, since this is all about me, 1997, I was involved in my first aid project, which was to design a wind turbine for Zimbabwe, for rural manufacture in Zimbabwe. And actually, the guys knew a bit about wind energy, and they said, we'll make it 250 watt rated and 3.6 meter diameter. Normally, a 3.6 meter diameter machine would be about 3 kilowatts or something. They recognized this is a low wind speed area, Zimbabwe. Let's see what we can do, see if we can make something locally that will be appropriate to the local wind speed distribution, which is all down here. There's no point building a machine that will produce 3 kilowatts over there if it never happens. What we need is a large diameter, and so we built the machine. Actually, it turned out to be a lot more difficult than they had anticipated to build the design. It needed laminations to be made for the stator where the coils are, and these laminations proved to be on the very edge of what a small engineering firm in the capital city could produce. So it wasn't the kind of village technology that they'd hoped. The company that did produce them actually got quite excited about it and started making them for export. And they did one village electrification project, but with the deteriorating political situation in Zimbabwe, it was very difficult to get diesel and stuff like that. And their main goal actually was to use it to export machines and get dollars into the country for the economy. So they were actually exporting, they called it African wind power, and they were exporting them. They exported a lot to France, quite a few to Scoraig, where I live, and quite a lot to the States. So that's kind of one model of using small wind for rural development. Yeah.
It was so difficult to produce these laminations locally. Why did they go down that route? Why didn't they just build it how you specified?
I was told to do it that way. I think they just didn't realise that this was going to be a big stumbling block. It's a very, very precise thing to punch a lamination. All the slots have to line up exactly. These were quite large diameter. You had a punching machine that would go ka-junk, 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 all second-hand stuff they got over from England. But they needed a very, very precise indexing wheel that would make those slots very, very precisely the same angle. And when you stacked up the stacks, they all had to line up, and it was touch and go whether they would actually get that working. They're very tenacious, very talented engineers, obviously, and they got it working, but it wasn't the kind of technology that you could use in a village workshop.
Are they still producing that, Hugh, or have they adapted it at all?
I think basically the political situation in Zimbabwe got to the point where it could no longer continue manufacture. He did try to manufacture them in South Africa, but he made some design changes and lost the US market due to a terrible design fault that caused a lot of recalls, and the agent in the States wouldn't buy any more from him after that. So it's a sad story, but it's a different model of rural development where you export the machine. This is the laminations. Basically, they're big sheets of steel with slots in them where you put the coils. These are the coils. And then the magnets turn around outside that, and the alternating flux of the magnetism through the coils generates your electricity. So a very, very simple arrangement. Very important with small wind to keep things simple. Because when you start making them complicated, there's just more to go wrong, and stuff does tend to go wrong. I said they should just use a brake drum off a truck, because I was really into using recycled stuff. That's the way that I've been working for years in the UK. And they said, no, that'd be much too expensive. Even a second-hand brake drum off a truck would be too expensive. Here, if people need a new brake drum for their truck, they take it to the guy with a foundry in the back street, and he'll make a mould from the old broken brake drum and cost you a new one much cheaper than getting buying one in from Germany or Japan or something way too expensive. So they don't really have scrap brake drums, because everybody wants them apparently. So they said, no, we have to make them much cheaper. And touch wood, it was cheap enough. That part of it was fairly simple to do, the cast iron drum that has the magnets all around the inside. This is the sort of alternator that I mainly used. This is what's called an axial flux alternator, where the magnets are facing each other. You put the magnets onto discs either side of the stator, and they face each other in opposing pairs, and then you wind a stator with the coils like a sort of pancake that fits in between them. So all the parts that you're making are flat. You don't have to make these curved things. You don't have any laminations because there isn't any core in the stator at all. This stator here, which contains the coils, is just coils and resin. It's quite greedy on magnets. It needs a lot more magnet material to generate the flux, because there's no iron in the stator to assist the magnetism in passing from one magnet to another. But it's much simpler to manufacture, and it's much has much lower parasitic losses and low wind speed. so it starts up very easily. So that's the design that I've mainly used. It was only the Zimbabwe project that I had to use these laminations. So in 99 or 2000 I got involved with what is now called Practical Action. In those days it was called Intermediate Technology Development Group. Mainly social scientists in my experience. There wasn't a lot of engineering or technology going on, but this was a technology project, and they needed an alternator for small wind turbines in Sri Lanka and Peru, so I designed an alternator using that axial flux technique. That's much, much easier to manufacture in a small village workshop, and that's basically kicked off the whole process of doing it that way, and empowering guys in sheds in the developing world to make and sell small wind turbines. In Sri Lanka, I don't think they made an awful lot of them. I did go back there and teach a course a few years later, and this one guy who I taught had made maybe 20 of them. But considering the cost of the whole thing, it wasn't really a tremendously gratifying outcome. I think John was telling me, John Leary, by the way, has a lot more, probably has his ear to the ground a lot more in the international development context than I have. So the questions to him more about the about development. But you were telling me hundreds of machines, or
No, I think 40 or so.
40 machines.
Udaya's built in Sri Lanka.
Not a huge.
Oh, in Peru, sorry. Yeah,
blossoming.
they've got to around 100 in Peru, yeah.
In Peru, yeah. This is now Peru. So they've taken it a wee bit further in Peru. And that's just, as I say, that organisation, Practical Action. Since the year 2000, I've been teaching courses where we get together and with some pieces of wood, some pieces of steel, copper wire, magnets and so forth, and we put together a wind turbine in the course of 5 or 6 days and put it up at the end, and it generates electricity. Very satisfying process. Wonderful thing to be involved in with a group of people. This is basically how the machine's put together. You've got wooden blades that are bolted onto an alternator. That's one of these axial flux alternators. And then the steel frame is very, very basic. I'd hesitate to call it engineering. It's a bit more like making a gate hinge or something like that. But the engineers really hate it because this tube, it rests on top of the other tube, and when you hold it and do that, it rattles. It's not being machined properly. It's not snug fit. But this is what I have found works. You see, because I've been making these things since 1977 or something. And initially, I used all kinds of roller bearings and stuff for the yaw of the machine, so it could weathercock. And I found I got all kinds of problems with the rain getting in and corrosion. And in the end, what really works, what's the most reliable, is just to have one piece of pipe drops on top of another, a larger piece of pipe on top of a smaller one, and a plate welded on the top, plenty of grease, and that would go on turning freely for a lot longer. So also the friction damping on that is beneficial, because what I do is I just allow the wires to dangle down inside this pipe. And obviously, if it turned too freely, they would get all twisted up. But if there's a fair bit of friction in that, then you can go for years without untwisting those wires on a good side. A very, very important part of this, without which it would be a complete flop, is the fact that it controls the output in high winds, and that's got to be done in a very simple and reliable way. In this case, the whole machine is mounted offset to one side, and that may have been puzzling me. Why is it off center? The wind, as it blows, is always trying to turn the machine away to the side, and you want it to turn away to the side at the right point. But the tail holds it facing the wind, so that it will generate useful power. But you reach a point where the force of the wind is strong enough, and you've got to the point where you do want it to turn away, that the tail will yield and fold and allow the machine to turn away from the wind. So it's what's called a furling tail. And without that, as I say, your machine would be quite fun, but it wouldn't last through the first gale would come along, it would burn out, fly apart. Very, very important part of any machine that you're going to leave unattended is to have some kind of governing system. And the simplest that I know is the furling tail. The machine is offset to one side, always trying to turn away, and the tail keeps it facing until the critical point is reached when it furls.
Is the tail, you have to move the tail back? Or is it spring
It's
back?
no, it's as if it were spring loaded, and I used a spring in the beginning, but the spring turned out to be the thing that caused the most problems on the whole machine because of the vibration and corrosion and so on. So then I went to using gravity. So this is actually an inclined hinge, and the weight of the tail. I mean, I didn't invent this, but it just happens to be the best way to do it. I figured that was, what I would do. I always like to use the best way of doing things. So the tail swings down into that position by its own weight, and it's as the wind gets stronger, you get more and more pressure on the blades, and more pressure on the tail, trying to hold it to face the wind, until you reach the point, and these balance each other so that it's facing the wind. But you reach the point where the pressure on the tail is such that it begins to lift on this inclined hinge, and that brings it closer to the blade. What happens is actually the tail goes on facing downwind, but it just lifts a bit, and all this yaws around a bit and faces off the wind, and that relieves the forces, and you establish a new equilibrium where it's generating less power, or probably about the same power, but the wind's stronger. So it's like a thrust regulating device. It regulates the thrust on the blades. If the thrust exceeds a certain point, the tail will lift, it'll move away, and that reduces the thrust and restores the equilibrium.
Does that cause much wastage when it's low winds?
Well, it does mean that it doesn't track the wind perfectly in low winds, and it's important to set this tail a bit. I use about 20-degree angle the other side to compensate, to try to keep it facing the wind. But it's true that it won't face the wind perfectly even in low winds. But a tracking error of up to about 20-25 degrees doesn't really seem to have a significant effect on performance. Once you get up to sort of 30 degrees or more, it begins to bite into the performance. But yeah, it's a good question. But because it's such a simple system, it does have defects for sure. One of its defects is in turbulent conditions, it's quite slow to react. You can't actually yaw the whole rotor really rapidly because the gyroscopic forces cause a lot of damage. It's important it should yaw slowly, but that obviously means that it doesn't respond quick enough, that if you get a real punchy gust that you will get a surge of power, and then when it's yawed out the wind, if the wind then you get a lull, then you get a dip in the power, and so that the power quality isn't as smooth as you would get with for example, a pitch control system where the blade pitch has changed. That has much less inertia and much more rapid response. Pitch control system is a superior system, but much more expensive, much more maintenance, and so it's a balance. I like to always find the simplest way of doing things. Blades carved from wood. Wood is actually an ideal material for making wind turbine blades. It was the most popular until recently. In fact, I think even recently in the Isle of Wight we were talking about, I've got a friend who works there for Vestas, and they made a lot of blades out of birch veneer. Wood is light and strong and fatigue resistant. The main problem is finding supplies of wood of consistent quality, actually. But it's a bit laborious to carve, especially for a beginner, and I think people get the impression that it's ridiculously laborious, but once you've done one, you find that the next one you can do twice as quick. It's one thing I'm working on at the moment, is to try to reduce the complexity of the blade carving process, because I like to try and carve the blades, the absolute optimum shape, but in fact you can get away with a much cruder shape. So that's something I'm actively involved in at the moment, is researching where you can simplify the carving process to make that easier. These are the magnets that I'm using now. These are very powerful neodymium magnets. They're these blocks here. They're widely spaced because they're very expensive, and I want to make the best use of them. You could get more power out of the machine by cramming those magnets in. As I say, because they're one of the most expensive bits of the machine, I space them out so that I can get lots of copper in the stator and sort of get the maximum from the magnets rather than get the maximum from that diameter of disc. These magnets have become cheaper than they were, say, sort of 20 years ago. They came down in price quite a bit about 10 years ago, and they became affordable for these sort of projects, the neodymium magnets. But they do have inherent corrosion problems that I've become very disgusted with over the years, because they do tend to go on and on. They're often coated in a foil. You can just see the foil coating here. And then I embed them in resin to protect them, but somehow or another they manage to corrode. And it's a bit like a corrosion of iron or steel. It kind of swells up, and so you get these magnets that are kind of swelling up, and the coating is bursting off, and they start rubbing on the stator. And it does seem to be quite a weakness with these neodymium magnets. Apart from the fact that they're very expensive, they also, in my experience, have quite a limited service life because of corrosion. Yeah.
Why in particular have you gone for those magnets?
They're just very addictive once you've used them. Once you've started using them, they're just, I mean, apart from the fact that the first few times you handle them, you come away with all blood blisters on your fingers because they really bite, you know, they'll flip around and snap together, and if they get a bit of your flesh, then it can be quite painful. But other than that, they're very, very sexy things because they generate a lot of torque, a lot of electricity at very low speeds. You can make really small alternators, very, very efficient. So like I said, they're kind of addictive. The previous magnets that I used, these ferrite ones, they're more or less indestructible as long as you don't overheat them. It's, I would say, about as easy to corrode a teacup as to corrode one of those, because you can just leave it in a ditch all its life. It would never think about corroding. It's a ceramic material. These are 3 times as powerful as the ferrite magnets. They're many times more expensive. And in the beginning, with practical action, for example, I was using ferrite because that was what was available. Over the last 10 years, I've been using the neodymium ones, but I'm actually going back now, more falling in love with the ferrites, because I've got machines, that I built in the 1990s where everything else has fallen apart except for the magnets. Whereas with these neodymium ones, what I'm seeing is the magnets are always the first thing to go wrong, corrosion of the magnets. So it's just something that I would share with you, that if you're embarking on an ambitious project, think about using ferrite magnets rather than neodymium ones, even though everyone will probably tell you that it's stupid because they're, obsolete technology and much more powerful ones are available now. And they may be right in saying that it's simply a matter of putting adequate protection in place on the magnets, but I think it's also a matter of buying high enough quality magnets, because I think quite often these corrosion problems are built into the magnets if you buy cheap ones. Yeah.
In terms of the cost, you were talking about the packing of magnets. If you packed out a ferrite one with the same cost of magnets as the neodymium one, could you get the same power? Do you know if that study is
if you spent the same amount of money on the ferrite ones,
that's right.
then I haven't actually done the sums, but what you would find is that you're spending a lot more on copper.
Right.
So it depends on the price of copper. What I actually, one of the things, I mean, it's maybe a hard thing to get across in a couple of sentences, but one of the things that I like about the ferrite magnets is that it does make a bigger machine, and the reason is that the neodymium ones are so small that they're difficult to cool, whereas if you make a bigger machine, you've got a bigger heat sink, and that might seem crazy because your precious wind energy, obviously you're not wanting to waste that in heat. But the reality is that these alternators are often too efficient, and they cause a problem with the blades. The blades would rather have a machine that's softer, if you like. And if you understand the concept of something that has such a lot of torque that the blades can't actually run fast enough to run at their best speed. If you have a machine that's very, very, very efficient, it will actually run at a constant speed that's related to the battery voltage. And that's not at all what you want for blades. You want blades to run over a whole range of RPM so that they run in step with the wind. The speed of the blades should be in proportion to the speed of the wind. And you can actually achieve that by having a less efficient alternator, lower cost, get the same overall efficiency using ferrite magnets rather than neodymium ones. So yeah, it's hard to explain, but for battery charging systems, actually having a less efficient alternator can actually be a better strategy than having a super efficient alternator. Whereas for grid-connected systems, the opposite is true. Obviously, you want to be as efficient as possible, and the grid-connect inverter will actually deal with the voltage interface between the turbine and the load to maintain the optimum speed for the blades. And you could say, well, why on earth do you have battery charging machines? They're inefficient, and they're batteries are really troublesome, and alternator efficiency is a problem, and so why don't you just go for grid-tied machines? Well, to my mind, if you're going to go for grid-tied machines, you ought to be building hundreds of kilowatts or several megawatt machines and putting them up on a hilltop, because that's the most cost-effective technology. If you're going to go into small wind turbines, probably what you should be doing is siting them on off-grid situations, taking them to a place where there is no electricity, and in that application, something that's very simple and that will charge a battery is the appropriate technology. In the UK, we've got a tremendous mushrooming of the small wind industry based on grid-connected machines, but even though they're more efficient, they're never going to be as efficient as a wind farm turbine, or as cost-effective. So for me, the place where small wind turbines come into their own is the off-grid situation, and that's why I think it's important to focus on battery charging technology. And you can put fancy electronics into it, but as I say, I think it's important to focus on stuff that's simple and reliable, because you're going into a context where people don't have the skills to maintain complex electronic circuits and can't afford to buy a new one. So you should be looking at technology that's simple and rugged rather than super efficient and complex. I don't know, yeah.
Sorry, just going back a little bit to a point that you made on the ferrite magnets. So you said that nothing really affects them apart from making them really, really hot.
You can overheat them, yeah.
How hot is that? I mean, is it the case that if you were in a developing country around the equator and it was very windy and your rotor was generating a lot of power, could they get so hot that they would be affected, or is it kind of in the thousands of degrees?
If your properly and your stator burned out, there would be a serious risk that the magnets would be overheated and lose their magnetism. You could remagnetize them in theory, although it requires a special machine to do that. But put it this way, it's not something that's ever happened to me. I live in a very hot place, but we're talking about 300 degrees C, so it's not. I think if the machine's correctly designed, you're not going to roast your magnets. So it's not nearly as big of a problem as corrosion. Whereas a lot of small wind turbines are put in coastal situations for the very good reason that that's where the best wind is. It's also a very, very corrosive environment. Often in the developing world, you'll be looking at a tropical situation as well. So a tropical coastal situation, corrosion is absolutely ridiculous, and this sort of thing would happen in a matter of weeks rather than years. Even though the ferrite magnets are less powerful, they're so robust that I'm definitely being converted back to them now. Get back into another story of a development project, because I think I'm probably getting too technical. This was in 2004. This really impressed me. These guys, Enterprise Works, had a really good modus operandi. They understood that you don't just go and dump the technology on people. You can't just go in and say, right, here's how to build a wind turbine. Now I've shown it to you, you'll be able to make a living. They really focus on making sure that they get with practical action, we were training like 1 or 2 guys. Here we were training 20, and they had a whole range of different skills, from small businessmen to winders of motors to welders to wood carvers. And then this particular project started off with the training phase, and then with the other projects that they've done, what they would do is they'd follow through with a business phase, a launch, whereby they would actually spend paid money on TV advertising of the product. Seems a bit quaint, but they recognise that you can't start a business just by saying, I can sell you a wind turbine. Nobody knows what it is, you know. So you have to actually establish a market. So they would do TV advertising of the product. They pass the leads on to the people that they've trained, and then the ones that took advantage and produced rubbish wouldn't get any more leads. So they do quality control to make sure that it was good stuff that was being spread in the marketplace. And then once the industry got well enough established, then they would be able to pull out and just let the thing run itself. But unfortunately, they didn't get funding to follow through with the second phase of that process here, for whatever reason. And so, although we did a lot of training, there was a guy in a shed who made a few wind turbines. Again, it's the same story. Manuel Kanzi, apparently, if you want a wind turbine in Ghana, you know, he's still the man who can make you one, which is nice. But it didn't ever quite happen. I suppose what we're looking at here is repeated examples of the idea that wouldn't it be a nice idea for people to be empowered by being able to manufacture what they need in their own country to make their own electricity, ideally in a rural situation, etc., etc. So far, I haven't really seen it happening, but there's more and more and more groups all over the world trying. So who knows? Maybe some of them will succeed. There's a group in France, Tripalium. It's an organisation that go around teaching the same courses, and they teach really a lot. You know, they taught hundreds and hundreds of people in France. Very, very popular in France. Similarly, in Colorado, there are guys who are using the same design ideas. But these are more, I suppose, running courses for what you might call hobbyists, enthusiasts. It's not, you know, within the sphere of the Engineers Without Borders goals of development. Blue Energy is an interesting example. They went to Nicaragua specifically with the aim of building small wind turbines, and I got really excited because I thought, this is great. They're going there. They're not just an aid project, and when the money runs out, that'll be it. One of their core aims as an organisation is to establish a small wind turbine manufacturer in East Coast Nicaragua in remote communities. There's never going to be any grid. There's absolutely no chance of any grid. They're coastal sites. And these guys know what they're doing, so we'll see what happens. Unfortunately, like I was saying, coastal tropical regions are horrendous for corrosion. Also, unfortunately, the wind speeds are more like 3 meters a second than 4. John's just been studying this stuff. Would that be a fair assessment?
Yeah, they're pretty low.
They're closer to 3 meters a second than 4, and you saw that bar chart about what happens to the energy as you go down to really low annual mean wind speeds. So, in comparison to using PV, to be honest with you, they were on the wrong track. I mean, the concept of being reliant on locally manufactured technology is a very nice one, but some of the pieces of the jigsaw puzzle were missing. The most essential one, the wind itself, was kind of missing in the case of Blue Energy. They've been quite successful in terms of publicity, getting lots and lots of volunteers. Lots of people have had a great time volunteering for Blue Energy in Nicaragua and expanded their horizons of the world and helped people in one way or another. But unfortunately, the small wind manufacturing side of it, once again, didn't quite work. This is a bench testing setup in their workshop, where they were measuring the output of alternators, and this is a whole community come together to get on the end of a rope, operating a pulley to raise a 20-meter mast to put up a machine to power their school at Monkey Point. So, I mean, this is the stuff actually in action, but as I say, there are some places that are better to do it than others, and I think although I'm very excited about the enthusiasm that Blue Energy went into this with, I might have done better to have asked them a few searching questions about whether they were actually going to a place that had enough wind before they started.
Can I just add a little bit to that actually? So as Hugh said, I went recently to visit Blue Energy and see how they're doing now. So that turbine there is still there, is still going, but a lot of the other ones that they've installed on the Caribbean coast of Nicaragua aren't. They're now in pieces, maybe in a scrap merchant or just lying on the ground where they were installed. They have done a recent project actually, a technology transfer project with another organisation that's working in Nicaragua but in a different region. So they're working in the Central Highlands where there is actually quite a lot of wind. Nicaragua does have world-class wind, equivalent to the wind resource that there is available in Scotland, but not in the region where Blue Energy are set up, which is on the Caribbean coast. So it just goes to show that it really is such a site-specific technology. It's something that can completely be useless in one place, and then yet you move a few hundred miles and it works perfectly. The stuff that Hugh was saying before about the amount of energy that you get from a given wind speed really does make the difference between viability and not viability of the technology. And the wind resource does vary a lot more than the solar resource. We were looking at a solar map of Nicaragua and a wind map of Nicaragua, and the solar one looks like a gentle little rainbow with lots of sun over on the Pacific side and not very much over on the Atlantic side. And then you look at the wind map, it's like someone's got a paintbrush and just splattered bits. There's a few bits in the Highlands and not much elsewhere, which is another difficulty of the technology, because you really have to prove that that resource is there before you put the turbines there, not this way around. Yeah, I think that's kind of what I was going to say.
So if someone was looking to put up a wind turbine, how do they decide if they have enough wind?
Well, one of the ways that you can do, the simplest way, is to look on a database. So this is what's commonly done for solar and works very well. So there are databases, NASA has quite a good one, there's all sorts of other ones which are based on satellite models and everything that shows you how much sun you'll get at a given site, like the maps that Hugh had earlier. You saw the one in the UK that showed how much sun is available in different places. If you put in your GPS coordinate, then it can tell you on this location you're likely to get this much energy with this size solar panel. You can do the same for a wind turbine, but you're much less likely to be right, because you've got a lot of extra factors in there, like you've got all the trees and stuff at the local level, you've got hills, you've got all the turbulence, all that kind of stuff, and all that changes. It's not like you can, even if it were possible to have someone to map all the trees in the world, the trees grow. As Hugh found out when he moved to Scoraig, then there were barely any trees there. They planted loads, and a lot of the windmills that they put there in the first place on towers that were way above the trees are now down dwarfed underneath the trees, so they don't work anymore. So coming back to your original question, the best way to do it is to put an anemometer there for a year. I say year because wind varies so much throughout the year. If you have, the solar varies throughout the year as well, obviously, but it makes a bigger difference with wind if you lose 2 meters per second in the winter. So you go down from 5 to 3 meters per second from the winter to the summer. It means you can use wind power in the winter, it's going to work great. But in the summer, you're going to be running, your batteries are going to be running pretty dry. Even if you measure for a year, though, there are still variations between years. So you can have enough wind one year and not enough the next year. It's a very, very variable resource, which is one of the reasons why it's more difficult and less popular than solar. Okay.
It's very, very, very difficult to actually assess a wind resource accurately, as John was pointing out. I mean, it can vary. It can almost be just moving 100 meters rather than 100 miles. But actually what it depends on is the amount of obstructions, mainly. I mean, there will be sort of broader geographical differences, like coastal and hilltop areas will be windier than inland, low-lying sort of areas. And there are obviously meteorological phenomena, weather systems and all kinds of stuff like that. But if you're looking on a very local scale, then it's going to be the obstructions that matter, and it's going to be whether you can get 10 meters above any obstruction that's around, or at least 6 meters above any of the surrounding obstructions. Is going to make an enormous difference, which isn't, you hardly ever see a small wind turbine sited like that in the UK because of planning restrictions and so on. So therefore what you're going to be looking for is open spaces. John mentioned that there are databases. There's a database in the UK which is basically known as the Knowable database, although it goes by all kinds of other names. But it's one where every square kilometre in the UK has been assigned a wind speed, but it's on the assumption that there aren't any trees or buildings in the whole place. And it's been abused really badly over the last 15 years or so by people who wanting to sell wind turbines. They say just type in your postcode, we'll tell you what your wind speed is. And you'll still find it being done now. That you can type in your postcode on a website and it'll tell you that your wind speed is 5.5 metres a second or whatever. I actually looked at the Knowable database for the Cannon Mills area of Edinburgh, which is quite a low-lying, heavily populated area, kind of close to the Botanical Gardens in the centre of Edinburgh, and it showed 5.5 metres a second, which is more or less what I've got on Scoraig, on the west coast. And I had the opportunity to put an anemometer on the sort of chimney pot of the house there at 10 metres above ground level. And at the end of the year, I'd got a mean wind speed of, I think it was 2.7 metres a second. And that's not only half the wind speed, that's an eighth of the potential for energy production. So it's not just a small adjustment, it's a massive difference. If you're in an area with a lot of trees and buildings, that you really need to think seriously about whether there's any point in using wind as an energy source, because the resource just isn't there, quite frankly.
What kind of level would you say it was worth having a wind turbine?
It depends on a lot of factors, obviously, like what the other options are. But typically it tends to be 4 metres a second is kind of marginal. 5 metres a second is beginning to get attractive. 6 metres a second is definitely attractive. That's the sort of thing. 3 metres a second, it's very, very unlikely that you would do anything, sensible with that, because there's so little energy there. Yeah.
How much depends on the efficiency of the blade itself? I mean, I realise that the outside.
Yeah, you're right. I have been glossing over that, and the reason I've been glossing over that is that the efficiencies, although they do vary, you might get a really, really efficient machine. You might get 50% more than one that's not so efficient. But when you look at the changes in wind speed, you're looking at getting 10 times as much. So that's really why I'm trying to focus on. And if you double the diameter, you'll get 4 times as much. So if a machine has half the diameter, no amount of more efficient design in the blades is actually going to get you as much energy. So really the diameter and the wind speed are the overriding factors. There are other less significant factors like the efficiency of the blades and the system as a whole clearly are going to be beneficial. But as I say, there are limits to what you can do. So there's a limit to how efficient you can make it. A practical sort of efficiency for a machine would typically be about 25% of what theoretically passes through the blades. Now the absolute maximum limit would be 59%. So if you look at the state of the industry at the moment, they're producing, getting on for half of the absolute maximum that they theoretically could. And they might be able to get closer, they might be able to, as I say, get a 50% improvement, but that's actually not going to be anything like as significant as the sort of differences that are made by making the rotor diameter larger or basically putting it on a taller tower and getting up into a higher wind speed. So that's, I'm going on and on about that because to me it seems terribly important, and you'll get plenty of people telling you that their wind turbine's the most efficient that's ever been invented. So I'm trying to counterbalance that by showing that there are differences in scale between what you can achieve with efficiency improvements and what you achieve by siting and by getting the correct diameter. Yeah.
What's the construction and maintenance cost for a turbine, and how does that compare with the construction and maintenance cost of like PV or hydro?
Well, construction, I would say, historically would be cheaper to construct a wind turbine on a good site for the amount of energy that it's going to produce. That's what makes it attractive. Is that you're looking at lower capital investment. I have to say, when we look at maintenance, that tends to be something that people don't see coming, but my experience is that you do get a lot more maintenance issues, or what you might more accurately call repairs, in a much shorter time scale than most people. A lot of people would say in their economic analysis that they're looking at a 20-year lifespan, and my experience is a 10-year-old small wind turbine is fairly old, and it's already had quite a lot of replacement parts by that time. So I think, yeah, if you're really going to be objective about the economics, you have to be fairly pessimistic until it's proved otherwise about the how trouble-free the machine's actually going to be. So it's I suppose I hate to be so negative about it, but it is a very troublesome technology, and so you need to go into it with your eyes open from that point of view, and recognise that PV is definitely going to be an easier ride, because all you have to do really with PV is connect up 2 wires. You can read loads of books about it, and you've obviously got to make sure you point it out the science. But in terms of the hoops that you have to jump through, it's much easier to generate solar power. It does have a higher capital cost, but that's plunging down at the moment, so it makes it harder to justify playing around with small wind turbines at all, to be honest with you, unless you live in Finland or somewhere where the sun doesn't even come up in its weeks. Yeah.
This may be a silly question, but in a load of your pictures, the turbines seem to be like up at an angle. Is that just because they're on their way up?
A lot of them are on towers that are being raised, because that's a dramatic moment.
I think right. I
Exactly.
wasn't sure if that was how they stayed.
That's the reason for that. It's not because when we actually finish putting them up, they will be vertical.
Right. Okay.
Here's another one at an angle. This is in what they like to call Palestine. These are some Israelis who are dedicated to trying to make peace with their neighbours, the Palestinians, and they go out into the villages in the West Bank where the Palestinians are being persecuted, and they put in a lot of PV and wind systems and stuff for them. And they also use these same designs of wind turbine. They would be interesting people to volunteer for, although I don't think that you would be able to get insurance for volunteer. But that would certainly be a good place to work as a volunteer. You get situations like this where the Israeli army come around and bust them and tear down the PV arrays and stuff. So this is a map. If you go to windempowerment.org, you'll find a map like this, and each of these is a group on different locations around the world who are using this sort of technology. Not all of them are doing it for development, but if you were to look in Africa, these are all people who are using small wind turbines for rural development. You can see very dense cluster in East Africa, for example. I think in Kenya there's maybe 3 groups in one country alone who are doing it. So there's quite a movement there, and to coordinate communications between the different groups and to help people to find support, we formed this association of organisations, Wind Empowerment. It doesn't have all that much to show other than the website itself at the moment, but that is kind of enough to my mind to basically provide, as I say, a network whereby people can find a way of getting into this process that's going on and find out what's happening closest to them or where they're going. So if you're curious about the use of small wind turbines for rural development worldwide, then it's well worth having a look at the Wind Empowerment website and following the links that you will get from there to the different organisations who are active in the process. So that's all the slides that I've got for you. But I'm very happy to answer more questions. Yeah.
Do horizontal axis turbines have any advantages? Have you ever used them?
I believe that horizontal
Or
axis wind turbines
vertical.
have higher, vertical axis wind turbines. I've never really seen convincing proof that they have a higher efficiency. They have some inherent problems. Essentially, the low-speed ones have problems of being too slow, so the efficiency of the alternator tends, you need to have either a gearbox or a very large, very expensive alternator that's potentially going to be a lot more expensive. They could be quieter, the very low-speed ones, but that's about all you could say. But in terms of being cost-effective, they're not competitive, and that's why you won't tend to see them actually successful in the marketplace. You'll see a lot of vertical axis wind turbine designs on the web with a lot of hype about them, but you'll very rarely see them in the real world. And if you do see them in the real world, you should ask penetrating questions about how much energy they're generating, because they're mostly just ornaments. Yeah.
Would you need to adapt your alternator design much for use with hydro in terms of the RPM?
Actually, I suppose the main problem with hydro is that it would probably be running at a much higher RPM, so that you would need to take steps to, or more steps to protect the magnets from centrifugal forces, such as, for example, machining a dip in the rotor that the magnets actually drop down into a lip, to restrain them, those sort of precautions against centrifugal force. But for hydro, you could actually build a much smaller alternator to achieve the same output because of the higher RPM that you would get. So that would work very well. Yeah.
Has anyone actually done that? Has anyone actually done that?
Not sure if they have. I've discussed it with a lot of people. I've done a lot of designs of alternators for people who were going to build hydros, but I'm not sure I've ever heard of one. One advantage is that most hydros you need to adjust the speed to get the optimum runner speed, and the ability to change the space between the magnets. You can alter the magnetic flux density by changing the spacing of the magnet rotors, and that's a nice way that you can tune the machine to work well with for example, a Hugh wheel at different heads. If you need to adapt the machine to the particular head on a particular site, it's very easy to adapt the speed of the alternator.
Didn't we talk in uni a while ago that said something about like ducted wind turbines on roofs in urban environments? Are they any good?
Well, my feeling is no. I mean, my feeling is that they tend to be hyped a lot. You will see a lot of marketing stuff about it. I can't see any. From when you consider the physics of the situation, I mean, it's all very well with hydro that you do want to duct the water and control its flow. The wind has no incentive to enter a duct. That's the basic weakness. So when you see a great big open door, okay, wind, come in here, and you'll have to go around here and down there, get pushed in there. The wind just doesn't bother, just just go around, So I think that's the bit that people miss, is that the wind is actually free to completely divert around all these complex ducting systems, unless there is something. I mean, you could get a situation where there's a building, with a hole through it, and then I've heard of such things, but again, I don't feel that that's an appropriate situation for a wind turbine. You get all sorts of noise, vibration issues. So I don't really personally feel that wind turbines and buildings mix terribly well together. But I mean, this is obviously my opinion. But on the other hand, I've never seen a successful demonstration of the technology either.
On your previous slide, can you go back?
The wind empowerment.
With the spread here, what are the driving forces behind the location of these ducts? It seems like where there's one, there's many, and then there's vast swathes where there's nothing. Is this to do with where the wind is, or
No, I
someone
wouldn't
sees
say
someone else
where
doing
the
it.
wind
like-
is. I mean, obviously, I suppose unfortunately, I cut off the bottom of the map, but yeah, there's quite a focus on doing them in areas where there are development projects. There's also quite a high concentration in Europe. The Irish are very enthusiastic, for example. The French are very enthusiastic. So these are perhaps more what you'd consider enthusiasts and less what you'd consider development projects.
Just following on from that, where do you see the future of small wind power being? Is it with enthusiasts, or do you see it being like rolled out as a technology?
Well, I
that
would like
is
to
viable?
think that, I mean, I must admit that the jury's still out on whether it can ever really be done successfully, but I would like to think that it's possible for local people to generate their own electricity from small wind turbines that are manufactured, maintained, and locally with local skills, and that should be a way forward to renewable energy and hope for mankind sort of thing, rather than just training people to be better and better consumers of products that are shipped all around the world with enormous consumption of energy.
So what do you see as the biggest barrier to that at the moment? Is it the ease of buying another technology? Or is there something
There is an
inherent?
argument that we should be using commercially manufactured wind turbines for rural development projects rather than encouraging local manufacture. And even quite a lot of these groups that do local manufacture don't want the end users to touch the machines. They basically want to do a factory manufacture in the country, but using relatively high-tech, highly skilled approach, which is not so accessible to the end user, and they don't necessarily want to involve people in the local community in the maintenance and that sort of thing. I would prefer to see a situation where it's as local as possible. But that's kind of more of an ideological or philosophical stand than any sort of logical or economic perspective there. Time will tell. Yeah.
Have practical action taken any of the wind further forward?
Do you know? Answer to that?
Yeah, so in Peru, they've built about 100 turbines now. They've done various projects, some very much like Hugh's hometown of Scoraig, where they've given each household its own wind turbine, some of them where they've built a big wind turbine for the community that they share on a mini-grid. I think in Sri Lanka that was also a practical action project, wasn't it?
Mm-hmm. Yeah.
Practical Action Nepal are also have been experimenting less successfully with the same design. They got some of the guys that Hugh trained in Sri Lanka over to Nepal to train them. Most of those machines have unfortunately fallen apart now. They are instead looking at using commercial machines. They've got quite a successful commercial project, or not commercial project, but a machine that uses a project that uses commercial machines going at the moment. Where they've actually paid for an engineer that comes from the company that manufactures them to go and live in the community for a couple of years to train the people in the community to look after it themselves. What I'm not sure about that is how does that work out in terms of the cost, because obviously that's a very expensive way of doing things, paying for that person to live there for a couple of years. So I think that's kind of where practical action are at the moment. There was a big debate a couple of years ago. Have you heard of a festival that they have every summer called Small It Is? It's basically a collection of loads of appropriate technology stuff, kind of like a showcase of all the stuff that they do. They had a debate there: is small wind an appropriate technology? And it was quite interesting. There were a lot of points against small wind. Small wind isn't. I don't think it can ever be disseminated on the scale that, for example, solar has been, because if you look at a map of the solar resource, how it's distributed across the globe, and the wind resource, you look at solar is highest around the equator, especially in Africa. Then you look at the map of where people are located that don't have access to electricity, most of them again around the equator, most of them in Africa. Wind is generally high around the poles, but there are some niche areas like Somalia, for example. In Mauritania, there are places that do have a fair number of people without access to electricity and a good wind resource. So there is potential for the technology. Whether practical action work in those areas is a different question. They definitely work in Kenya, and they don't really use the technology there. But as you can see on that map, there are quite a few other people that live in Kenya that are using the technology, so maybe they can be more successful.
See, earlier you were talking about the fact that PV will never really be manufactured locally because it can be done so cheaply.
Too high tech.
Yeah, when you're talking about things like ferrite magnets, is there any chance that those could ever be magnetised locally, like in Kenya, where there are groups doing this?
Well, the actual magnetisation is fairly low tech. Yeah, you just need a great big coil and a capacitor, and you just charge up the capacitor and go whack and put a pulse of very high flux density through the thing and magnetise it. So that's not a high tech thing. It'd be relatively expensive to set up if you weren't making a lot of machines. But as far as actually making the ferrite material itself, I don't know. It's certainly not nearly as high tech as making the neodymium magnets. So I would imagine that could also be done. I think the problem. The Chinese kind of took over the whole of magnet manufacturing just because they were so cheap and competitive. And now they've suddenly started pushing the price up. People are realising that they ought to have kept some neodymium, manufacturing capacity in the West. And they're struggling to re-establish it.
Would that be a similar story with the copper as well? Because I know that gets mined quite a lot in Africa. Is it processed a lot? I mean, does it have to be processed elsewhere? Or?
Yeah, I don't know, but it's. I would say that the ferrite magnets are much lower technology than photovoltaics. So it's a much more accessible technology, and there's been in the last few minutes a lot of, well, solar is more competitive and wind is less competitive. I think you also need to keep in mind the hybrid perspective, that the two of them are much greater than the sum of the parts, and that a bit of wind along with PV is the best of all. Even if wind has some weaknesses and PV has some advantages. Wind blows at night, for example, and in the winter, I think that the hybrid concept, the mixture of the two, is something that you should always have in mind with these sort of projects. Yeah.
It's actually a question about the practical action when you use the commercial turbines. Does that tie into one supplier, like if you need spare parts or to repair things, or is it pretty transferable between turbines at that scale?
Pretty much does tie them to that one supplier, yeah. I mean, some basic things you can make, like the tower, for example, you'll almost always manufacture that in the country in which you're using it, even if you buy the turbine from China. But yeah, if you need a spare blade or something, then you need to go and find that same Chinese manufacturer and hope they're still in business and order a spare part, which is going to cost you quite a bit of money to post just that one bit. I mean, to post a whole turbine, at least you can split the shipping between the whole cost of the turbine, but to pay that same shipping on one blade and the import taxes and everything, that's one of the biggest advantages of using designs like Hugh's, that if your blade breaks, then you can make another one, and it costs you very little, and the supply chain is very simple. Hugh's, where Hugh lives, is the ideal situation. If one of his neighbours' turbines breaks, then the supply chain is Hugh, as long as he has a spare piece of wood lying around somewhere, can carve him a new set, and then it can be back on in a couple of days, ideally, as long as Hugh doesn't have other things to do. If you buy one from China, then it's going to take you at least 2 weeks for it to get posted there, and that's an ideal situation.
It's a little bit like the bicycle or even the motor car, I suppose, that if there were no mechanics who understood how cars work, and you were just to give someone a car, it would break down and that would be really. And I think small wind turbines are kind of in that position, that people have unrealistic expectations of them for a start, and then as soon as the battery goes flat or there's a minor bad connection somewhere that nobody can actually understand what's going wrong, then it's going to get neglected because there's no culture of understanding it's the familiarity process basically. And as familiarity develops and as the number of machines increases, then you get more and more mechanics who are skilled and competent to maintain them, and that therefore becomes much cheaper. So rather than having cost and delays and so on, having it all at the local level is the kind of thing that can only, it's a critical mass, I would say, is what I'm working towards. You need this critical mass of experience with the technology, and that's what hasn't yet been achieved, I would say, with any of the projects to date. But who knows? Maybe within the next few years it may get achieved. But I think it's an inspiring concept, the idea of local manufacture of small wind turbines to meet local needs, and I think people will go on trying to do it. And I think it's a very enjoyable process from the engineering point of view to participate in. And I'm a bit of a pessimistic person, so I can't really say that I'm confident that it's ever going to work, but it's certainly fun trying.
Something that Hugh hasn't mentioned actually is that the fact that you can manufacture something locally then gives you an extra educational opportunity. I mean, there's so many people here in the UK that have no need for a wind turbine because they're not living off grid, but have had a great time and learnt a lot from building one of Hugh's turbines, myself included. And part of the difficulty of using complex technology such as small wind turbines in rural development projects is, do the people that live in the community where that's been installed understand how to operate it, how to maintain it? And we've seen with small wind you really do need someone there that is capable of picking up the pieces when they fall apart, because they definitely will, it's guaranteed. One of the projects that I visited recently in Nicaragua, they'd done a really good job of transferring knowledge to the end users of the technology, because they'd got them involved with the construction. So they'd got people from this community to come and take part with the manufacturing of this wind turbine. So just in the way that myself and hundreds of other people across the UK have learnt about how a wind turbine works through building it, they did exactly the same, and that project has now been really successful. People there know so much about how the machine works. I learnt quite a bit from them, even though I've spent the last 3 years of my life studying the technology. I learnt quite a lot in terms of little tips and tricks of how to look after the machinery. So it really is a fantastic opportunity, being able to manufacture the technology near to where it's used, and really is something that can help promote a much more sustainable system that will ensure that the technology is still operating in 10 years' time, rather than in pieces like the ones that I saw on the Caribbean coast of the same country.
Yeah, I think that is the big danger, basically, is that you kind of parachute in and install something, and then you say, bye-bye, make sure you top up the batteries and